So, good morning to everybody. I hope that you hear me. Just a raised hand, just to be sure that everybody's hear me. Okay, perfect. Thank you very much. Thank you for your participation here in this training. I welcome you. I'm Vasiliki Drosou. I work in CRES, in the Center for Renewable Energy Sources, and this training session today is organized in the framework of acceleration program of our project, SolarHub project, that I'm sure that you are already familiar with this. If not, you can always visit our site, SolarHub. I will give you the exact details in the comments later on, or maybe Celine could do it if you want to learn and to be updated with more information. So today we have a training for our lovely solar thermal technology, and I'm happy to be here with all the partners of Athens ecosystems, namely CRES, with my collaborator, Dr. Rosie Christodoulaki, that will present the applications of solar thermal technology. But also we are here with E2. Let me check again so as to be sure. Yes, the Technical University of in Turkey, where Sevan will present the technologies, of solar thermal technologies, and then Harry Michalopoulos, owner of the company Samler, a company in Greece with great exporting activity, will present specific aspects related to exporting requirements, activities, specific cases, and other important and very interesting aspects. And last but not least, Leopoldo Miko from SolarHub Europe will give us a very interesting presentation about standardization and certification issues for our solar thermal technology. We'll have a break. The program, I think it's already familiar to you, but in the first session, we will have two presentations from Rosie and from Sevan for solar thermal applications, and then for the case studies. And then we will have a short break. Each presentation will last for 30 minutes. After the short break, we will have two presentations from Harry Michalopoulos and from Leopoldo Miko. And then, of course, we will give room for questions or issues that we want to discuss. In the meantime, if you want to write in the comment list, I think it's possible to give some questions so as to keep track. You're very welcome to do it. Nothing else from my side. The whole activity have duration of 3 hours from 10 to 1 set Brussels time. Thank you again for your participation here, and we are ready to start with the first presentation from Sevan. Sevan, the floor is yours. You can introduce yourself, share your presentation, and start your presentation. Okay? Toba is here.
Okay, thank you, Vasiliki. He's out of his class. He's connecting at the moment. So I would like to introduce our team, SolarHub ITU team. We are representing Istanbul Hub for the SolarHub project. In Energy Institute, Dr. Sevan Karabetoğlu, myself, Tuğba Okutucu, and Dr. Üner Çolak, he's also here. We are representing Istanbul ecosystem, solar ecosystem, and we are going to talk about solar heating and cooling theory, mostly theory, because after our presentation, CRES team will be talking about the applications. Please give us 2 minutes so that Sevan can share the presentation. And he did not report any connection problem, so he has the correct link. I will be waiting for him to join.
Okay. I'll take the opportunity not to announce, but to speak about our demonstration day that will be held in Izmir in December. And let me check the specific date.
It's December 12th.
December 12th. This is going to be in December, yes. Celine, would you like to give some more information, taking the opportunity that you have 2 minutes?
Of course. In honor of our ignition program, the first phase of this SolarHub Accelerator program, we will present our program inputs, the outputs, at the end of this year, on 12th of December in Izmir. Ege University, in fact, will be organizing and hosting us, and we will be welcoming our program beneficiaries. In fact, these people will be from Turkey, Greece, and other countries from Europe. They will be presenting and demonstrating us their progress, what they have done, and how they actually use these pre-designs, which will be a part of today's program as well, and integrate that pre-designs into their project ideas as well. Soon we will be informing, of course, all you with regards to registration as well. We hope to see you there. Thank you so much.
Yes, great. And I'm sure that we will have more information on our site for the people that they are interested to get more information, or is going to be distributed about the agenda and such details.
Soon it will be all distributed, and we will have an open registration site.
Okay, perfect. Very good. And also taking the opportunity of this time gap, I want to mention that the presentations will be available after the end of this session. We have already discussed with Celine that some way you will be able to receive the presentation and maybe the recording. I'm sure also the recording. Yes, and last but not least, I don't want to forget to thank cordially IDI and Celine for the organization and the dissemination of this event. Tuba, are we ready to start with Sevan presentation?
Yes, he is here among the participants. Let me check. Okay. I just spoke with him. He said, I think he's waiting. Waiting to join. I told him that both links are okay because the first one did not allow me, so I told him to try both. And sorry for the delay. He should be here with us in a few seconds. Yes, he joined. I think he's going to share the presentation. Sevan Hocam, it's your turn, so you can please share your presentation and start.
Hocam merhaba, sizi sunucu olarak atadık ama duyabiliyor musunuz bizi?
Şimdi mikrofon açıldı.
Süper, çok sağ olun, hoş geldiniz.
And also I will open my cam.
Okay, thank you so much.
So,
And
hi
we are so
everyone.
sorry for the delay, okay.
Yeah, I'm sorry for my lecture. So I share my screen.
Okay,
I guess
we see your
yes.
screen, but not in presentation mode. Try to do it in presentation mode so as to be more
Sorry.
visible.
Okay. This is all right or same? You see this now? Properly?
Yes, but not in presentation mode. So maybe you
Sorry.
can, yeah.
Sorry. Let's see for the first monitor, maybe it's better like that.
Mm-hmm.
Yeah. And this is presentation mode. Is it okay right now?
Not yet. Maybe you try to close it and to reopen it in presentation mode.
Maybe let's see. This is for the
Mm-hmm.
nuts. Yeah, that's I guess now I can place like that. So it's okay. I guess this is the part, but I should make it like that. And I guess it's okay.
Not yet.
Not yet.
Hocam, it's not, but I don't think that it's going to be a problem if you don't
It's
have
okay.
a speaking
Okay.
notes.
Okay.
Okay, thank you so
Go
much.
ahead. Thank you.
So
Okay.
Yes.
sorry about that. So I'm trying to discuss with solar heating and cooling systems for the properties and some general aspects, starting with active systems, spacing heat and service hot water systems, and solar cooling, and also for the modeling of this solar heating based. And I will select some of the topics, not for the whole case, because we have a limited time. So let's see, for the active solar systems, we have a water and heat.
Sevan Hocam, we don't see your slides moving. You're on the first page.
Okay. Bir saniye hocam. Bir paylaşmayı durdurayım. Tekrar bir deneyeyim. Let's see for the whole screen and first screen. Now you see the PowerPoint like that. And also I will make that. Is it okay? I guess.
Yes, full screen now. Thank you. Yeah.
Okay. So in active solar systems, as I said, in which water and or heat transfer fluid is pumped through the collectors. So for we can use the water heating and space heating and also cooling using the solar active systems. But especially in cases where there is no basement in your let's say space, this space is required for the additional equipment like hot water cylinder or some thermal storage. Then it's difficult to retrofit in your houses. But eventually we can manipulate the systems to embed our solar active systems for commercial and some residual parts. So actually 5 types of systems are can be listed as a direct circulation system, indirect water heating system, air heat pump, and pool heating. And as I said, I will not get the details for all of them. I just select 3 of them. First of all, let's start from this direct circulation systems. Here we have a pump for actually directly circulate the water itself. In the storage tank, there will be embedded with the collectors, of course. So there is enough available solar energy to increase its temperature, then return to the heated water back to the storage case. So in the system, a single storage tank equipped to the auxiliary water heater, because the demand should increase by the usage. So there will be additional auxiliary heater, electrical based heater to the collectors. And there will be important feature of this configuration for a check valve, because we have to prevent the reverse thermosiphon circulation due to the energy losses, and the pump is not running. Therefore, we have some precautions for that. So pressure reducing also is a problem. So these valves and pressure relief valves are required. However, when the steel has not enough pressure for the high level of, let's say, building. So again, these systems should not be used in areas where the water is extremely hard or acidic, because there will be corrosion on your pipes or any devices embedded with these systems. So again, another important part is a freezing. So these direct circulations can be applied only if freezing is not frequent. So the weather conditions should not be harsh. Therefore, we have to prevent these harsh conditions if you want to implement that directly circulation systems. And one disadvantage of the system is there is a power failure, in which case the pump will not work. So all the heart of the system is pump. If pump is not work, then there will be no circulation. So the heat transfer should not be occur with these cases. So there will be some additional protection for, let's say, for the electrical pumping. And then for the indirect water heating systems, there will be heat transfer fluid is circulated through the closed collector loop to a heat exchanger, not directly. So for commonly, heat transfer fluids are actually glycol water solutions to prevent the freezing. And other transfer should be silicone oils or refrigerant can be also used. And some protection devices, such as, again, expansion tank and pressure relief, are also required to protect the system for increasing pressure of the collector loop, and additional overshooting of temperature should be, again, for avoid prevents should be implemented. And when fluids are non-portable or toxic, are used double wall heat exchanger, because any leakage of this toxic material, vapor of these liquids should be hazardous. Therefore, we have a double wall heat exchanger for that cases. And also it can these placed around the tank, mantle, or externally, like that. You see the difference between this external and mantle heat exchanger. So again, for the indirect water heating systems, again, freezing is the worst case of our active solar system. Therefore, we have to, first of all, pump is hard, as I said, so there will be electricity protection, and also freeze protection should be supplements for that cases. Then drain bake system is implemented for indirect water heating system. So this system circulates water through the closed collector loop to the heat exchanger and the portable service filter. So circulation continues as long as solar energy is available, and the circulation pump stops the collector fluid drains by gravity and drain back tank. So if the system is pressurized, the tank serves all an expansion tank with the system here, and operating, and in case it must be protected with the pressure relief valve, because we don't want to get back to the drain bed tank. So these are two indirect and direct are circulating water. In this case, if you want to warm up a space with air, we use air heating systems. Therefore, circulation will be supplied by the fan instead of a pump, of course. So the electrical loads are less than the water pump. So in the systems, the main advantage of the system is air does not need a protected from freezing or boiling. This thermophysical phase change are not occurring in this case, and non-corrosive also. So we can use, we don't suffer any heat transfer fluid degradation. Additionally, cost effective, because as I said, electricity consumption is less. But they have a disadvantage that air handling equipment like ducts and fans are more space than piping and pumps. The hydraulic diameters are larger, of course, for the liquid circulating pipes. Therefore, the volume or void of the, let's say, the system is larger than the water circulating system. And also the system can be used to heat water, not for only space heating, but the loads should be, heating loads should be high. Therefore, the mass flow rates should be increased. And in that heat exchanger, there will be a heat transfer to the potable water and also circulated through the heat exchanger and return to the storage tank. So, of course, if the demands, for instance, the warming up the water, not for the space, and the mass flow rates is large for water heating, therefore, auxiliary heater should be implemented on the storage tank. And also intermittence of the solar energy, the solar tank charge duration should be less. Therefore, the auxiliary heater, again, in a control like PID control units, should be supply the demands. So these for the, let's say, active systems for indirect water or air heating systems. And also we have a space heating and service hot water. We have two demands for that case. So active solar space systems use collectors to heat the fluid. The inlet of the heat comes from the sunlight, as you know. So storage units store the solar energy and it's supply the demand. So provide the solar energy to the heated spaces like space heating or service hot water. So size of the solar system is usually determined by the life cycle cost analysis. Of course, first of all, you have to define the net demands of your house. Then you have to size the collectors area and let's see the number of the collectors. So load as an individual or some several components. We cannot, we will see the modeling. We will define the load as several parameters. So cooling, heating, or combination with hot water supply will be enlarge the system. If your demands, types of the demands are increased, then your cost and the amount of your system will be enlarged. So in solar system, collectors during daytime absorb solar energy, as you know, and then get the heat up the working fleets. So first of all, we have 5 basic modes of operation. This slide is actually important, depending on the existing conditions. So we have an amount of demands, but also the mode scenarios can be changed. So by knowing these scenarios, could be change the capacity of the system. So first mode is when solar energy is available, so it's okay, and heat is not required for the building. Then it's called a charge of the thermal storage. And when solar energy is available and heat is required in the building, then that will be a discharge. But we can supply from the solar energy. However, for the solar energy is not available, then our storage system, thermal storage system, will be on the circuit. So the stored energy is used to the supply, but time duration will be limited, of course. So charge and discharge durations are not same for thermal energy storage, as you know. Then when the 4 scenarios is the solar energy is not available, heat is also required, and storage unit has been depleted, then auxiliary heater RV on the load demand. And finally, when the storage unit is fully heated, there is no load which will charge fully, then meet the collector is absorbing heat, solar energy is discarded. Okay, that's the 5 modes of service hot water. So for air systems, space heating by air, for all processors, the collection, storage, and the delivery, liquid system use water and water plus unfreeze solution for the collection. And there are many variations of system use both solar space heating and water production. We can combine, and it will be controllable for the demands, changing demands, not statics, maybe dynamic demands could be assembly for the system. And for the, let's say, for in basic combination of for air system has a components of collectors, pebble beds, storage unit, thermal storage units. We drive the air in fan and ducts. So we have a three-way damper, and also we have auxiliary heaters. So that's the basic heat air system. Air system is not practical to have simultaneous addition or removal energy from storage. So of course, these systems, both hot water and space heating, should be implemented with the thermal storage, because the bottleneck of these systems are the intermittence of the solar energy. Therefore, thermal storage based or implementation should be well sized and designed, because we cannot assume or cannot let's say procrastinate the cases or conditions of the weather. So here is the more detailed case of the airspace heating system. There will be subsystem. We have a preheated tank and some auxiliary, let's say, resistance for hot water supply. There will be combination for both space heating for hot air and also service hot water. Therefore, the capacity of thermal storage should be increased, but also you have to implement some additional auxiliary resistance. So we have, of course, air to water heat exchanger to supply the hot water. And also the hot air is circulating to the space that we want to heat for the building. And then there will be circulation modes after the releasing the energy to heat up the space. Then collectors again for the charging mode. If there is no demand, then pebble bed storage should be charged. If there is demand, then and as I said, for the scenarios there is no demand, you have to charge, and if there is no sunlight, then you have to discharge the thermal energy of the storage. And water systems is more complex than the air system because we can use hot water both for directly and also space heating. And then if your demands are types of demands are increased, then your system will be complex and the cost will be, of course, high, as you guess. So here I have three-way valves and also auxiliary heaters to supply the excess demand. Also, the heart of the system, of course, there will be pump, but the thermal heart is the main storage tank, because we transfer heat from collector to the working fluid in this main storage tank. And if your demand is service hot water, then there will be then implement a hot water tank, and this water will be supplied from the tap. So additional, if you want these, for example, you don't supply for the service heat water, you just use the stored thermal energy and want to heat up for the space heating of the house. Then this thermal energy should be transferred for the circulating air in the with the fan and ducts to the house space, let's say. So I just skip this part because I talk about, and then heat pump systems is the fourth, I guess. In that case, we have a heat pump and also implement with the collectors, of course, and main water storage unit is just coupled with the collector and heat pump system. And we have again a ducts circulating in air. So these heaters are warm up the air, and the supply air are warming up the space. So heat pumps actually better than the, as you know, for the direct electrical resistance, because COP values are nearly 4 or 5 for the heat pump mode. But for electrical heaters, the COP values is 1, as you know. So we can implement these heat pumps with these space heating and service hot water, and this efficiency due to these high levels of COP heat pump values, the efficiency of the system and the consumption will be less, and the efficiency will be high. So high demands of hot water or space heating will be provided by using these heat pump systems instead of implementing thermal energy storage. Okay, so the series configuration usually preferred to the parallel and solar collector power will be used, leaving the tank at low temperature. And also this allows some solar system to work more effectively till the next day. And also heat pump performance is higher than the operative temperatures, as you know. We have a complex control system because your demands are dynamically changed and the conditions, weather conditions should be changed. So you have to optimize and automatically select what kind of demands should be satisfied for choosing space heating or service hot water heating. Or also mass flow rate control should be implemented to the system to utilize or optimize the total thermal storage of energy. And also we have a solar cooling, of course, for the intermediate seasons in hot, dry climates. Process like evaporative cooling can offer energy conservation opportunities. However, in summertime for higher ambient temperature, low energy cooling technologies cannot alone satisfy the total cooling loads. Therefore, some vapor compression cooling systems are usually used for that cases, powered by electricity, and also expensive and large systems. So in that high temperature ambient conditions, we can implement solar energy based cooling systems. Therefore, we can decrease the consumption of the electricity for the vapor compression, and then COP values for refrigeration will be higher by using these solar collectors. So, of course, reducing the conventional vapor compression also reduce the effect of global warming and ozone layer depletion. So, economically and environmentally is a better solution for solar cooling. And I choose one of them, but there will be three types of solar cooling: solar absorption, solar mechanical, and solar related systems. But we will focus on only absorption units. Here we will have a absorption cooling cycles for the cases, and we use a sorbent, some solutions based on some ammonium, but in commercially nowadays we use lithium bromide. So let's see for the parts of this cycle, thermodynamic cycle. We have to separate its left side and right hand side. At the right hand side, the vapor, pure, let's say ammonium or lithium, is sending to the absorber, and there will be mixture of solution. Then this solution is pumped to the generator, which reach, let's say, if you use lithium bromide reached strong solution is going to the generator. In the absorber, there will be some mixtures for creating solution, but this process is actually, let's say, exothermic process. Therefore, you have to reject some heat from the absorber to utilize the reach of the strong solution, richness of the strong solution. Then sending this solution to the generator, there will be again input of heat because we have to vaporize the, let's say, lithium bromide. Then this pure vapor is actually sent to the condenser, and then the rest part is working as a refrigeration cycle, and the other part, right hand side, is used as a, let's say, heat pump. So again, the circulation of the vapor from condenser to expansion valve and the evaporator, the pure, nearly pure vapor is again sent to the absorber, mix a solution, and also heat exchangers use the waste heat and get the weak solution to add to the absorber. So the amount of, let's say, or vapor of this liquid or substance will be maintained constantly concentration. So where is the solar part of this system? Is at the generator input of heat. So if we implement these solar collectors to the generator, heat is actually supplied from the solar energy. Therefore, there is no like combustion heat addition parts. Then also these parts are circulating liquid instead of vapor. So pump works is actually very large amount of rather than this enthalpy difference and heat, let's say, heat generation. Especially we can says that 1% of this total Q in is actually equal to the pump work. So we can neglect the pump work for the output of the heat released. So as I said, I just skipped this part, but you see that absorber are collect the pure substance. We have a solution, then solution pump to the generator with strong solution. Then there will be heat implementation. So there will be vaporization process. This vapor sent to condenser and get some heat rejection from the space that we want to cool. That's the cooling part of the space, and this is the inner part. Then we can circulate these again, complete the cycle. So that's the absorption, lithium brom water solution based absorption solar cooling system. So I just skip, I just tell them. So you have to have an assumption for it. Of course, for the heat exchangers, the effectiveness should be less than unity. So you have to see that this temperature control, and you can change the heat exchanger capacity for that. And also cooling is actually, we have an evaporator heat rejection, and we just get input to the QG. And also we have a pump work, but as I said, pump work is actually negligible rather than the QG. So the COP of the refrigeration or cooling is defined like that, and it's actually a function of these states of enthalpies. So if you have the mass flow rates and enthalpy conditions for energy balance, and mass balance equations should be satisfied for the thermodynamic analysis of the system. And selecting some independent parameters, you can optimize the COP and capacity of the cooling by this analysis. So finally, I have a modeling part. I will talk fastly for that case. We have two actually methods for that. First of all, F-chart method, which is based on actually simulations. And also this can be used for if you have any chance to access a simulation program. You can use this F-chart method for your solar ratio of your system. So there will be for that demands, for supplying this demand, we just use the solar energy. And this fraction, the F, gives us the for the interval of time interval for, let's say, a month or a year. Then the fraction is calculated which amount of energy is supplied by the solar part. So we have a definition for F and some parameters for our collectors. And then the two ratios are these parameters actually have to calculate it, which is non-dimensional parameters, but it's related with the temperatures, collector area, and also some other parts. This should be English, sorry about that. So we have a ratio of F prime of FR, which is again related with the mass flow rates, heat capacities, and some heat losses, thermal heat losses. So we have some additional empiric equations for that ratio for the collector optimization. However, you can put the values as a single 0.94. And that's the idea of defining these F, which is total F times LE over total LE. And these fractions, these Fs are function of X and Y. So X is defined as the ratio of the collector losses to heating loads, and the other one, the ratio of absorbed solar radiation of heating loads. So X is related with the losses, and Y is related with the absorbed solar energy for the same heating load. Okay, so that's the parametrical relation is actually gathered from the several simulations using transits, and then they have some correlation for that. So if your X and Y's are calculated, then your monthly based F values are calculated, then you can get some ratio of that part for annual solar ratio. Which means how much percentage of your system is supplied by solar energy. So we have some thermal energy densities from solar. It depends on your, of course, site of your geographic position, and also X and Y are calculated monthly. Then with sum all for months by multiplying these F values, and FL over L, total L, gives us the solar ratio, which means annual load fraction supplied by the solar energy is like that. So it's actually related with the collector area. By choosing collector area, you can define the solar ratio, which means in that case, if you use 75 meters square of collector area, then annually the half of your demand will be supplied by the solar energy. That's the how it works. And also last slide, as a Transys, we have a modeling and simulation softwares like Transys in the transient, not a steady state. So it's actually driven for the solar energy systems like collectors, parabolic roof, or other parts. But then it's generalized for the single thermodynamic analysis in the transient mode for dynamic cases. And there will be several databases and of course some another utilization like hydrogen production, and also photovoltaics panels are implemented in the database. So you can use some commercial photovoltaics panels to drive like pump to implement both solar thermal and photovoltaics in a single project. So you can dynamically sense or measure of the flows. So you can optimize your system, and without any construction or manufacturing process, you can first design your system in simulation mode. And also it's the main advantage is behaves as a transient, as a dynamic part. So you can give the response, and some control-based analysis can be done by transistors. So several experiments can be done on simulation way. So after optimization of the system, you can get the manufacturing process like that. So I guess that's all. And thank you for your attention.
Thank you very much, Sevan. Just to remind you that you can always put questions in Q&A. Celine, is this correct?
Yeah.
People are
Yes,
allowed
they are,
to?
yes.
Okay. So we can see, and then we can handle appropriately in Q&A session towards the end of this activity. Thank you very much, Sevan. And here we are ready to proceed with the next presentation by Dr. Rose Christodoulaki. Rosie, are you ready to share your screen so as to hear about applications? We see your presentation, but not in presentation mode.
Okay, I will fix it. Can you see now? Okay, let's start
And not in
again.
the presentation mode, Rosie.
Okay. Just a minute. Okay. Can you see it in presentation mode?
No, but maybe if you could try to click on the other pages. So if we see that it moves, so you don't have to put it in the presentation mode, you can leave it as it is, I think. If you don't have notes, of course.
No notes. No. It's strange because in my PC, it seems that it is in presentation mode, but obviously it is not. Is it good, Celine? Can I proceed without presentation mode?
Yes, but maybe if you can try to change the pages.
Yeah.
Is it?
I'm in page 3 now.
No, we are only able to see the first page, the cover one.
Okay. Now?
Yes, it moves, so you can use it as it is. Okay.
Okay. All right.
Okay, thank you. Good luck.
Sorry for this. Yeah, it's okay. So, good evening from me. I'm Rosie Christodoulaki. I work in the Center for Renewable Energy Sources and Savings. I'm a physicist. I have a PhD in solar thermal cooling and a master in environmental design and engineering. I have been working in the field of solar thermal heating and cooling over 20 years. And today we will present you the case studies on solar thermal for heating and cooling of industrial and non-industrial applications. Hope you like it. Any questions, any queries, please do not hesitate to disturb me, and I will be very happy to answer in all questions. So the contents of this presentation is to present the case studies in solar thermal applications in industries and non-residential. So looking at the worldwide map, the solar thermal applications in industries is shown in this map with the red and blue dots. And this map has been taken from the SIP Plants Info website, where all solar heating for industrial processes are depicted and are recorded there. So you can see that all over the world, there are such applications in industries, and they aim to decarbonize heating and cooling in industries. Now, regarding the solar thermal in industrial applications in the largest case studies, you can see in this map again, we have very big installations in Australia, in Oman, in Chile, Spain, Denmark, and China. So here, the largest applications in terms of installed capacity are depicted in this map taken from the International Energy Agency. And this table shows the industrial applications worldwide ranked from the largest installed capacity to the smallest installed capacity. We are talking about big installations over 1 megawatt thermal. So you can also see the date of the commissioning of the system, and all systems are pretty much new, dated from 2011 and on. Now, what the figures say about these installations in industries? Well, as you can all imagine, the global industrial heat demand is expanding, is rising year by year, and the same will continue to happen until at least 2028. And with this, the share of fresh renewable energy sources in the global industrial heat consumption will slowly rise, approximately 3% from 2022 to 2028. Higher rise is expected for solar thermal heat compared to the other renewable energy sources technologies. And this rise is expected to be more than 160%. So 30 megawatts of new projects are starting operation within 2022 in Europe, China, and the United States. And that's why there is this high rise of 160% in industrial processes only. So this leads to a total cumulative global capacity of more than 850 megawatts. Continuing the industrial applications, the market share of the industrial applications, we can see that the solar industrial heat is on a growing path. We have more than 300 megawatts of additional capacity that are expected to start operation within the period from 2023 and 2026. Some of them have already been inaugurated. We will have 62 plants being planned, and half of them will be in Europe. The Middle East and Southern Europe are the main target regions for solar process heat, possibly due to the higher solar irradiation. And we can also see that the projects are getting bigger and hotter. The proportion of systems supplying temperatures above 100 degrees Celsius is rising. So we have new projects being hotter and bigger in capacity. Now, which industries typically can use solar thermal? Basically all. Some of them are most prominent for this use. So the industries that typically use solar thermal, and we have seen it in most of the applications globally, is the agriculture, food and beverages, textiles, chemical industries, and automotive industries. Why this? Because they use low to medium temperature ranges, which makes them ideal to use solar thermal heating and cooling. So let's start in the first case study of industrial applications, and this is in Moguntia meat spices in Tyrol. It has been installed in 2007 with a capacity of 150 kilowatt thermal. That corresponds to 215 square meters of collector area. It has a storage volume, heating storage volume of 10 cubic meters, and it can produce a daily hot water of 8,000 liters with the solar fraction of 45%. In which processes does this system is used? In the cleaning of the containers for spices, in the cleaning of dispersing machines, in the hot water for processing liquid spices and pastes, and in the dehydration of production halls during the summer. The temperature range demand that this system can supply is from 30 to 110 degrees Celsius. So you can see that this system, the solar thermal system, has a wide range of a wide temperature range of supplying the demand. And the heat carrier is the water and steam. Now, the second industrial application that we would like to show you is the Prestage food in North Carolina in the United States. It started operation in 2012. It is actually a poultry company, so it processes meat, chicken, and the installed capacity is 7,800 square meters of flat plate collectors, and has a large heat storage tank, 10 tanks of 85 cubic meters each. The daily hot water demand of the industry is 570 approximately cubic meters per day, and the solar fraction of the system is 50%. What does it mean? It means that the system, the solar thermal system, can supply the 50% of the total heat demand of the Prestage food factory. It is used in the cleaning processes, which are a lot in that specific factory, and the temperature range demand is over 60 degrees of Celsius. And in this picture, you can see the diagram, a simplified hydraulic diagram of the processes. Now, continuing the industrial applications, we have a brewery, the Goss Brewery. It is quite renowned in Austria. The solar thermal system started its operation in 2013. It consists of 1,500 square meters of flat plate collectors, and it can produce heat of 527 megawatts per year. So this is it corresponds to approximately 380 kilowatt hours per square meters of aperture area, of collectors area. The solar thermal system has a solar fraction of 19%. Considering that it is an industrial application, this solar fraction is very high. So the solar thermal system basically produces the can cover 20% of the industrial heat demand, and it is used for the massing processes and supplies heat over 87 degrees Celsius. In this solar thermal system, it is also in industrial application. It is based in the roof of the Gatorade PepsiCo factory in Arizona, in USA. It started operation in 2008, and it consists of approximately 4,000 square meters of flat plate solar thermal collectors, and has also a big hot water tank, not one obviously, but several, that all are added to 114 cubic meters of hot water. The heat production, the annual heat production, is estimated at 1 gigawatt thermal. That corresponds to 1,200 kilowatt hours per square meter of aperture area per year. The solar thermal system is used for the preheating of fresh water for the soft drink production, and it supplies heat in a temperature of over 35 degrees. In this industrial application, it is also a meat factory, burger meat factory in Austria. It started its operation in 2013. The installed capacity is approximately 1,000 square meters of flat plate solar thermal collectors, and also it has a hot water tank of 60 cubic meters. The daily hot water demand of this meat factory is approximately 190 square meters per day. And the solar thermal system is used for the dehumidification of maturation chambers and the preheating of the feed water for the steam boiler. This solar thermal system produces heat at the temperature range of 40 to 60 degrees of Celsius. Now we have also in Greece, in Thessaloniki, in the premises of Olympic Brewery, a solar thermal system. It started its operation in 2023, so it is relatively new. The installed capacity is 1,900 square meters of collectors, solar thermal collectors, and it can produce heat that is estimated at around 340 megawatt hours per year. The output of the collectors is, that is, the collectors can produce heat at 150 degrees of Celsius, and the solar fraction of the solar thermal system is 70% of the pasteurization process, because this solar thermal system is used only for the pasteurization of a brewing process, and it is also estimated at a total heat demand of the factory at 2.2%. We have also a video that it is in this link, so you can visit after this presentation to see the installation. In Greece, there is also, among other installations, obviously we have a lot of installations of industrial and non-residential installations in Greece, but we selected two to show you here. And also the next one is also in Greece. This installation is also for a brewery in Harma in Crete, in the island of Crete. It started its operation in 2008. It is a relatively small system. It consists of 12 square meters of flat plate collectors, and it is used for preheating the processed water. To my knowledge, this is still running, and also it has been extended. The solar thermal system has been extended and has been hybridized with also geothermal cooling system. One of the oldest and biggest solar thermal installations in industries is this of the Serantis Cosmetics, which is based in Attica in Greece. This solar thermal system is also still running. It started its operation in 1999. The installed capacity is 2,700 square meters of flat plate collectors, and it can produce heat of 1719 megawatt hours per year. This is divided into cooling production and heating production, because this system does not supply only heating, but also, as you can see in the figure below, it consists of two large lithium bromide absorption chillers. So it converts this solar thermal heat into cooling energy. So this heat production, this amount of heat that is produced, is divided into cooling production of approximately 1,100 megawatt hours, and in heating production in approximately 600 megawatt hours per year. The collectors can produce heat at a temperature of 75 degrees. And as I said earlier, this heat is either distributed to a cooling loop or to a heating loop. So this solar thermal system is used for the preheating of the processed water, of the space heating in the form of a hot water at 55 degrees Celsius, and for space cooling and refrigeration via two absorption chillers, each one having a cooling capacity of 350 kilowatts. Now we start to present the applications in non-residential premises. So the first one is in Singapore, in the United World College of Southeast Asia. This is a solar thermal system installed in 2011. The capacity is approximately 4,000 square meters of solar thermal collectors, flat plate. And also, this heat is stored in a total storage capacity of 60 cubic meters. It can produce heat, and the amount of this heat, the annual production is 1,600 to 2,200 megawatts per year. This solar thermal system can produce the whole hot water demand for this college for 1 year. So the solar fraction is 100%. And not only this, it can also produce cooling energy, and with a lithium bromide absorption chiller of a capacity of 1.5 megawatt, can also produce air conditioning, can also cover air conditioning needs of this building. So this solar thermal system, it is used for two processes: the hot water for students, for the students' campus, and the air conditioning of the building. Now, another big application, non-residential application, is the Hyatt Regency Aruba Resort and Casino. It started its operation in 2013. At this point, I have to say that a typical non-residential application of solar thermal systems is in hotels, hospitals, and campuses, because these buildings use hot water, and they are ideal candidates for the solar thermal applications. So this is a hotel, this is a big hotel, it consists, this solar thermal system consists of 500 square meters of solar thermal collectors, flat plate, as we can see in the roof of the hotel. And also it has 26 cubic meters of hot water tank. And also it is used for the hot water of the hotel residences and the hotel uses for shower, kitchen, laundry, and so on, as well as cold water for air conditioning. Another non-industrial, non-residential application in Sweden is that of the district heating system. It started early operation in 2023, and it consists of approximately 2,100 square meters of collector. The output of the collector is from 73 degrees of Celsius up to 120 degrees. The installed capacity is 1 megawatt, and the solar heat produced in the park is sold through a heat purchase agreement, HPA, with the local district heating supplier. So you can see another application, another potential application. This is in a district heating in Sweden. Now let's see the solar thermal in non-residential applications, and especially in district heating. So you can see from this report of the IEA, International Energy Agency, we can see that 336,000 cities use solar thermal systems for supplying heat to the towns and the residences of the cities. So we have 336 solar thermal systems that are used for district heating. And you can see this geographical distribution across Europe. We have 256 plants in Europe with a total installed capacity of 1,372 megawatt thermal. And outside Europe, we have 80 plants with a total installed capacity of 537 megawatt thermal. Now let's continue to the non-residential applications, and more specifically in a hospital application in Germany. As I said earlier, hospital applications are typical applications for solar thermal systems. So this system started operation in 2014. It consists of approximately 800 square meters of flat plate collectors and has a storage tank capacity of 30 cubic meters of hot water. Annually, the solar thermal system can produce 320 megawatt hours per year, and this solar thermal system is used for the hot water of the hospital residences, of the heating of the building, because the solar heat feeds into the existing district heating grid. So it also heats the building, and it is also used for air conditioning during the summer months with the aid of an absorption chiller. Solar thermal systems are also used for office cooling and not heating. In the Caribbean, we see this example. This solar thermal system is used solely for office cooling purposes, and in a less extent for domestic hot water and heating. And heating. So this system started its operation in 2012. It consists of approximately 1,000 square meters of flat plate collectors and has also a storage tank capacity of 11 cubic meters. And as I said before, the bulk of the heat production is used for office cooling. So with this, I will close this presentation. I think that we have presented many applications which you can be inspired. There are a lot of applications in Europe and in worldwide, as you have seen, and we expect more in the future to be built, and we are very happy because solar thermal heating and cooling is one of the most prominent technologies, and it is also supported by the relative legislation, at least in Europe. Thank you very much.
Thank you very much, Rosie, for this presentation. We are exactly in our timing. So this means that we can close this session. Give me a second. So we can have the break according to the program now. And we'll be back in 11:35 set time. And we will continue with the presentation of Harry Michalopoulos, and then with Leopoldo Miko, and then with the Q&A session. So thank you very much. Stay connected. Write in the Q&A your questions, if any. And we will meet again in some minutes in 11:35. Thank you. Okay, here we are again. I hope that you had a nice break. And we are to proceed in the second part of our activity. So we are ready to hear Harry Michalopoulos from Samler Company to give us his experience for exports. Harry, you're here. Okay, we're ready to see your presentation.
Okay, 1 second.
I think we lost him.
This is what I see also. While Harry was trying to share the screen, maybe accidentally pushed the wrong button. Let's wait a little bit.
Okay.
Let's hope that he will rejoin.
Okay. Maybe we can also proceed with Leopoldo's presentation.
Yes, this is a good idea. Leopoldo, are you here with us? Do you hear us?
Yes.
Okay.
Just a moment to open the presentation and I'll share my screen.
Always
Okay,
ready.
wonderful. Thank you.
Perfect. Thank you, Leopoldo.
Can you see me?
See you, yes.
Okay, very good. So one is done and now I'll share the presentation.
Hello?
Hi,
yes,
Harry.
Suddenly you disappeared and we consider that's a good solution to proceed with Leopoldo, but it's up to you if you want to. Would you like to make a last try to see whether it's possible to share your screen to see your presentation?
Let me check.
If you encounter problems, okay, now it's coming, I think. Seems black, something happening, but not successfully. Harry, seems that also I see that Harry is stuck. Okay, let's proceed with Leopoldo. And in the meantime, I will call Harry to check what is going on.
Okay. Thank you, Vasiliki.
Thank you, Leopoldo.
I'll share my screen. I think I'm some slides. Okay, now you should see the presentation in presentation mode.
Yes, fastest slide of today.
Very good. Hello, everyone. I'm Leopoldo Mico. I'm head of operations at SolarHub Europe. SolarHub Europe is the European Solar Thermal Industry Association. So we have as members most of the value chain of solar thermal in Europe and someone also outside Europe. And today I will speak about standardization and certification. I hope you will bear with me. We had already 1 hour and a half of very nice presentations from my colleagues, but let's dig in this topic that is very important, especially from a market perspective. First of all, what is standardization? Standardization is a way to create proper way of building and testing products. As you can see on the screen, standards are a formula that describes the best way of doing something. In Europe and also connected to outside Europe with another organization, SEN, so the European Committee for Standardization, is the one in charge of dealing and creating and revising standards. As you can see on the screen, one specific technical committee within SEN is 312. That is the one that is dealing with solar thermal, and they created and they are revising when necessary the 3 standards that you see on the screen. So EN 12975 on collectors, 976 on factory-made systems, and 977 on custom-built systems. Standardization activity of SEN are steered by the technical board, who has full responsibility for the execution of SEN's work program. Of course, standards are prepared by technical committees, as I mentioned, and their work is based on national participation by the SEN members. All European countries, but also other affiliated countries are participating in the standardization work, and delegates represent their national point of view, let's say. This principle also allows the technical committees to take a balanced decision that reflect a wide consensus. So standards are created by national level, by experts, and those reflect what is the European and beyond Europe situation. One thing to remember is that as SEN in Europe, we also have ISO as international organization that is connected through these standards with the ISO 9806. This is the first introduction of standardization, and now we can move to the key mark. Key mark is a voluntary third-party certification mark. The key mark demonstrates to the end user compliance of a product with the requirement of the applicable standards we spoke about before. More than 20 years ago, SolarHub Europe and SEN, in close cooperation with leading European test labs and with the support of the European Commission, developed the Solar Key Mark. The certification mark has multiple benefits, such as assuring the end consumer that everything is fully tested according to the relevant standards, also allowing manufacturers to introduce new products in different European countries. We will see also more benefits to the 6 main stakeholders of the network. Once you test the collector once, it's recognized everywhere. The key mark is recognized in Europe and beyond. And the key mark certification in general can be established for all products where there is a European standard. So it's not only solar thermal, but also heat pumps and other different things. More in the specific, today we're talking about solar key mark, and that is one of these key marks owned by SEN. And as I mentioned before, it needs to be compliant with one of the following European standards for collectors, factory-made system, and custom-built systems. When we talk about collectors, we have, of course, different types. We have flat plates, we have high vacuum tubes, we have concentrated collectors, so like the one you see in the different pictures. And they are also for different applications. So we have residential application, we have non-residential, like it was very well explained by my colleague Rossi. So we have application on hospitals, on commercial buildings, and also we have application for district heating, as you can see in the last screen, and for general industrial applications. So this is the main standard that is regarding collectors. The second one that is relevant for the solar key mark is the factory-made system. Those systems are not only the collector, but they also integrate generally storage, as you can see in these pictures. For example, in the first case, we have a thermosiphon. First and second case, we have a thermosiphon system where the storage is integrated on the top part of the screen. And the last, we have also a thermosiphon system where the storage is on the back. Those collectors are made by also members of SolarHub Europe, so you can see different type of option. These types generally are for residential use, but also you can find some in smaller applications on non-residential. Last but not least, sorry, but there is a mistake. This should be 77. Custom build system and storage. Those are mainly relevant for storages. It's a standard that is less used than the other two, but of course it's also for specific installation and specific system, so that everything is tackled and everything can be thoroughly analyzed and tested for the solar key mark. I think, okay. Here I can show you how the solar key mark works. So we have the initial product testing with the quality management. Once the collector is tested, the collector is taken at random in the production. So both the manufacturer and the end user are assured that all the collectors will work the same way. Then we have a periodic surveillance of the product every 2 years, and the production surveillance every 1 or 2 years. This ensures the end user and the manufacturer that the manufacturer on one side will not have to test again every year, because their product will be thoroughly certified and tested. And the inspector will also be able to join the manufacturer site and continue ensuring the quality for the end user. These are 3 of the main stakeholders in the solar key mark. So we have test labs, we have plenty in Europe and in affiliated countries like Switzerland. We have inspectors that are not only Europe, but also all over the world and connected to the testing laboratories. And then we have the certification bodies. At the moment, we have 10 in Europe. We have them in many European countries, and those are the ones responsible for issuing the solar key mark certificates. One important aspect of the solar key mark is the transparency of what we do and the certificates. Well, you can see on the screen a QR code that leads you to the solar key mark database that now I will share on my screen. And you should see it now, I hope. Yeah, okay. So every product that is certified by solar key mark can be found in the solar key mark database. The database, of course, is divided in 4 categories. We have collector, tanks, system, and controllers. For each of the certified collectors, for example, you can find the license number that is connected to the data sheet that will load in the meantime. You can see the brand, and if you click on one of them, let's go, for example, on maybe let's pick. Okay, I don't know which one I can pick. Okay, I'll go with this one. You can see all the information regarding the manufacturer, regarding the collector, and also the different test results. So you can see the thermal results. Here you have all the information you can need. You have also the optical results, and then you have annual output, general power output. All the information are transparent. The data sheet are accessible. Okay, this doesn't work in the specific. I'll try opening another one. And this certificate values for the family of the collectors. What is the family? A family is a collector with similar construction measures, but different size. So if we have a collector that is within certain limits that you can find also on the Solar Key Mark website, the manufacturer doesn't need to test all the different type of collectors, but he can build a family. With this, he will have the different options. As you can see, if you change to another collector in the same family, you will have, of course, different results because the size is smaller or bigger. And this also helps the manufacturer on saving on costs, because testing, of course, is expensive, but it's important also to ensure quality to the end consumer, to ensure quality to public authorities, because one of the very important things that we will see later is that solar key mark in most European countries is connected to subsidy schemes. And subsidy schemes are also a way for manufacturer to enter new markets and sell their product on different markets. Let me open one datasheet so that we can see it together. I will open this one. Okay. So this is the datasheet. On top, you will see the certification body. In this case, is the Insertco in Germany, and the test lab that is carrying the testing, Intertech in this case. Here you can see license number, when the certificate was issued. That is very important. And then the different information of the manufacturer, the information of the product. So everything is fully transparent, and all the work of the Solar Keymark is available on the Solar Keymark website that you will find later the link on this presentation, but we also will share, or feel free to contact us for more information. So all certificates are available online, all active certificates are available, and you can find them at the Solar Keymark website under database. You don't need any specific approval, but everything is accessible. As for the database, all the other documents of the Solar Keymark network are available under network meetings. You will find the minutes, you will find the agenda. One of the key points of the network was always to be transparent and to work together with manufacturer, but also with different internal and external or extra-European organization to improve the quality of the Solar Keymark, because it's important to ensure the quality of the collector that are sold in the European market. Going back to the presentation. Now you can see on the screen the let's say Keymark main stakeholders. We have consumer that are assured by the Keymark that the product they buy and they install is of high quality and that follows all the European standard active, and that all the tests were carried and verified the quality of the collector. We have manufacturers that with the Solar Keymark are able to save a lot of money in testing, and they are able also to connect and sell their product in different countries, because as you know, in every country in Europe, but also beyond Europe, have specific requirement to sell the product in their market, and those requirements are tackled fully in the Solar Keymark certificate, from a colder climate, like it can be Northern Europe or other places, to more warmer climates. So we can see also North Africa and Middle East. We can also see the Sunbelt region. All those are tackled by the different testing of the Solar Keymark. The inspectors are able to join the network and also participate in this work of growth of the Solar Keymark. Testing laboratories are the main one, one of the main categories, one of the main stakeholders, because they are the one carrying on the testing. And the main added value also is that they are able to further improve their testing methods and procedures with other test labs across Europe, but also beyond. Then certification bodies, as I mentioned before, they are in charge of issuing the certificate, and also they are the guarantee of the certificates. And then we have public authorities that are able to create subsidy schemes, being sure that every product that is certified by the Solar Keymark is a high quality product that is not going to have issues on their markets. That said, the Solar Keymark certificate at the moment counts a bit over 1,100 certificates in 17 different countries, and we have a network of over 300 stakeholders. And as I mentioned before, here you can find a website where all the information are available if you are interested to know more about the Keymark. One thing that is very important to mention is that the Solar Keymark is working together with other relevant standardization and certification bodies outside Europe, as DCL, for example, in Dubai. We have also connection with Shamshi in North Africa, also with SRCC in the US, so that we can ensure in the future, but also for some of them already now, that the Solar Keymark works also as to, let's say, overcome trade barriers and market barriers for the consumers and for the manufacturers also in other countries, not only in Europe. I think that this is it on this part. So thank you for your attention. Maybe we have some more time regarding the Q&A. But we also have before Harry. I don't know if Harry was able to fix with the presentation.
Thank you very much, Leopoldo. And just to mention that the database in Solar Keymark is a kind of guarantee. I mean, you can check the database, and if a collector or a system is in database, then this means that it's certified. If not, then this is something important. I mean, or we can easily have this database as a guarantee. And also that there are some working groups also available in the SolarHub site, where everybody can join depending on the interest that they are fully open, with just an email to your attention or to my attention. And there everybody could check, and considering the interest, business can ask to join this working group. Perfect. Thank you very much. Of course, we'll have the Q&A session where you can write down your question and them in the session after the presentation of Harry. Harry, are you there? Thank you very much, Leopoldo.
I don't know. I hope I will make it.
We will do that.
Let me try to share.
You are exporting in more than how many countries? 10, 15?
Oh,
So I'm sure that you have the capacity. Okay, perfect. Perfect. It's not a presentation mode. Just try to do
because
so.
it's me trying it just in case, you know.
Okay.
So, but is it okay now, Harry? I can do it for you if you want.
I don't know. Let me try if I can share my screen.
Okay.
Let me.
It seems like a black box. Okay, maybe we'll move on with your suggestion, Celine.
Yes, why not, Harry? May I try? Oh, he's also, I think, something happens whenever he tries to share his screen.
I'm sorry, it seems not possible to share the screen. If you could help me, so it would be great.
Yeah.
Okay. Wait a second.
Okay.
Is it good now?
It's not in presentation mode, but it's.
But for me, it is in the mode, you know, But as long, do you see that?
It is now perfect.
Okay, wonderful. Okay.
That's perfect. Okay. Hello to everyone. I'm really sorry for these technical problems. Okay, we found a solution. My name is Harry Michalopoulos, and I'm the managing director of the company Samler. Samler is a solar thermal collector producer located in Greece, and is considered as an exporter, as we are exporting in more than 48 countries. Next page. Can we change the page?
The problem was it was not moving, you know.
Yeah, let's stay in this mode. I think it's
okay.
Just to be. So in my presentation, we will talk about product certification. Let's say we will see the most important certification schemes around the world, and of course always under the aspect of market. The second is market segmentation. That is going to be about product differences and on which markets are mainly sold these products. The third part are some market analysis. This is just some random countries. Obviously, I couldn't present all of them, so I just pick up some randomly. And then also some barriers we are facing for the export of solar thermal products. Next page. Okay, so of course, Leopoldo fully covered before about the Solar key mark, just the previous page. Okay. So the key mark is the mainly certification. I don't know. I see the next one. Okay, good. Key mark is, let's say, the main certification for the European market. As Leo mentioned, key mark is a voluntary third-party certification mark for solar thermal products. And the most important is to show to the end users that the product is of fine quality and conforms to the relevant European standards. And the key mark, as I said, is mainly used in Europe, but of course it is also recognized in many countries worldwide. For example, in Chile, in South America, key mark is fully accepted and actually is recommended. The Solar key mark, is a SEN European mark scheme, which is dedicated to solar thermal collectors according to 12975 standard. Also to solar systems, solar thermal systems, according to 12976 standard, and of course to custom build systems for storages, controllers, according to EN 12977. So the key mark is fully covering the requirements for solar thermal products. Is a very good tool for our exports. So as a manufacturer, I could say that this is, let's say, the passport for increasing our export activity. We can go to the next one. This is a scheme which is mainly in North America. This is the OG100, OG300. Of course, there are even more. From SRCC. This is the Solar Rating and Certification Corporation, which is specialized in solar thermal products. So in SRCC, the two important for us are the OG100, which is related to solar thermal collectors, and OG300, which is related to solar thermal systems. Both of them are very similar to key mark, and they have a similar layout. So in the database of SRCC, you can find the certified products. So you can check details about their efficiency, optical results, and so on. This is this kind of the OG100 and OG300 are mainly used in North America, but also are accepted in other countries which are close by, especially in America. Also, a lot of subvention schemes are based on the results of OG100 or OG300 certifications. For example, I could say in Puerto Rico and some others in Caribbeans. In addition, there is also the Energy Star certification, which is mainly for solar thermal systems. Energy Star is a more general certification, which is for many different products, like household appliances, even televisions, and many different others. Of course, are included the solar water heaters. This is also a certification which is used not only in the United States, but also in other countries, even in Asia. But definitely is a requirement to have the OG100 or the OG300 certification. The next one. So in Australia, there is another product certification which is called Watermark. So this is Watermark is administrated is a certification scheme which is administrated by the Australian Building Code Board, which is actually related to the product, but also to the installer in a house. And this is established in 2006 by SAI Global, and of course right now is run by is administrated is transformed. Sorry, let's say it's transferred to Watermark. The scheme was developed in an attempt to set some minimum requirements to protect potable water sanitary systems from contamination. And of course, to ensure the drink water quality that will not be compromised by poorly manufactured products, components, and of course, labor work. The Watermark is mainly in Australia and New Zealand. We do not meet this kind of certification in other areas. Can go to the next one. Now, another certification requirement is like an approval, is mainly in United Arab Emirates, but this is accepted in the close by countries, but mainly in this setup in Dubai. But of course, all the rest Emirates are also using this certification. So to get the DCL approval, the importance is that you are, for example, Solar Key Mark certified products. First of all, sorry, we talk about collectors, not systems. This is important, but it is basically for collectors. So the most important is that the collector is Key Mark certified. Then you can apply for the DCL. So with the necessary processes, you can get the approval. This is mandatory to sell in the Emirates. The similar situation is they have created a platform where you can see all the products with the approval. And at the same time, on this database are linked the importers, the producers, and all relative models. So even if we talk about OEM products, it has to be mentioned who is the real producer of the product. The next page. Now, another country which has a certification scheme is Israel. So in Israel, you get an approval from the Standard Institution of Israel. This approval. It is mandatory that you test the products. Unfortunately, the tests right now can be done locally. So, for example, test reports or any other certification from a European recognized laboratory or from United States are not accepted. So you have to done tests of each product in according to local standards. To be honest with you, recently the committee is discussing to accept or to adopt, let's say better, the norms, the European norms, let's say EN 12975 or EN 12976. This practically in a solar thermal system, you have to apply for two tests. The first one is about the solar collector performance test and structural and material tests according to SI 579 standard, Israeli standard. And the second is about water heaters. So over there, they just check the electrical safety tests, some heat losses, performance tests, and some structural tests. As said, these standards are very, very old and are based on American standards, but we talk about standards of something like late 60s. So it's something very old. So for sure they have to update. Next page. Now another big headache is in Saudi Arabia. Over there they have there is the Saudi Standard Metrology and Quality Organization, and so they have created SASO, as it's called, the Quality Organization SASO, which over there is a web-based application which called Saber. So everybody has to, all producers that they want to export to Saudi. So each export they do, or let's say each import in Saudi, you have to apply in a platform. Theoretically, it's a little bit complicated because this platform is not well designed, I could say. So standard like EN 12975 is not fully accepted. So there are always some problems. There are many efforts even from SolarHub Europe, but also some European labs and certification bodies that they are trying to support European producers to export in Saudi. Under this program, SASO has issued technical regulations for regulated products based on their nature, application, safety, and performance aspects, which include risk to consumers and the environment. According to each product, they are classified as low, medium, or high risk products, and so on. Sorry to say, it's a little bit complicated process. Personally, as a company, we have found many difficulties to develop a standard business in Saudi because of this process. Next page. Now, there is, let's say, quite recently, there is an organization which is called Global Solar Certification Network, which it's a very important tool for manufacturers, for exporters, because under this organization, you can get, let's say, a passport and finally to be able to sell in different continents. The aim of Global Solar Certification Network is to facilitate cross-border trading for manufacturers and other suppliers of solar thermal products. So the main objective is to minimize the need of retesting and recertification on each new country where, as a producer, decide to sell products. The concept is to implement for solar thermal collectors based on the test procedure given by the ISO 9806 standard. So this is, let's say, as international standard is accepted for some other certification bodies. Therefore, it makes our life easier. The Global Solar Certification Network is in cooperation between solar certification body schemes around the world, also test labs, and of course, and producers. So when a product has been certified by one of the participating certification bodies, the product can obtain certification from other participating certification scheme without retesting of the product and without inspection of the production facilities. It's really make indeed our life easier, and of course it helps producers all over the world to expand their activities in other continents. Also, there is part of the GSEN is also a cooperation with the SolarG. SolarG is a label which makes much easier to identify the efficiency of a collector. So based on GSEN cooperation, you can obtain the SolarG label for different continents and for different certification scheme. As you can see in my screen, for example, you can have the SolarG and the key mark, and of course for Europe, but at the same time you may have a label, a different label, for example, issued by SRCC for United States or Asia or Australia. So it's another tool for exporters. So these were a few words about the certifications around the world. Then we can go to the next slide, where we can talk a little bit about market segmentation. So of course, I mentioned some basic products. Of course, there are many different other options for solar thermal. As we have seen before, solar thermal applications are enormous. So the first we can discuss about is the natural circulation system. So this is a very basic solar thermal system. This product is mainly for countries with high sun radiation. So we meet these products in Mediterranean, in Caribbean, in Middle East, Australia, and of course countries close to equator. Allow me to comment that from all my presentation, I have excluded China, which is it's a huge it's a huge market with many different characteristics. But okay, let's focus a little bit on some other markets. So this product doesn't require any kind of electricity, any kind of connectivity. So it is a fully autonomous system. It works in a natural circulation way. The main advantages is that it is a very low cost system, and at the same time is a very reliable solution. So that makes this solution ideal for low income families, and definitely a solution for energy poverties. Many incentive schemes and of course many actions even from United Nations and from many organizations, worldwide organizations, are supporting the sales of thermosiphon systems in areas with very low income, like let's say in Africa or Latin America, because of the simplicity of the system and of course the low cost, offering in the lowest cost hot water to users. The main markets where we can meet these kind of systems are Israel, Cyprus, Greece, Australia, China, India, and of course also many others. Next page. The second category, let's say the second category are the forced circulation system for domestic hot water. These kind of systems are mainly for countries with mid and high sun radiation, like Europe, US, and Australia. These systems are considered as high-end, offering a lot of options, and but also at the same time are of higher cost. These kind of systems are compatible with other technologies like heat pumps. Also, they are offering a higher aesthetic in a house or in a villa, where the collectors are adapted perfectly on the roof, and at the same time, all the rest equipment is located on the basement of the house. The main markets for such systems is Italy, Germany, France, Australia, United States, and probably others as well. Next page, please. Now, in addition, there are forced circulation systems for domestic hot water, but also space heating. This is mainly for countries with medium sun radiation, but at the same time, high demand of heating. So any energy provided by the sun is very precious because the cost of energies are very high. This is considered as high-end solution and of course at high cost. Obviously, as you understand, solar thermal cannot be the sole energy of the system, so it is required to be combined with other heating technologies such as heat pumps, gas, or even oil or any other. The main markets that we meet these products is Germany, Austria, Switzerland, and France. Next page, please. Another thing is DC heating. DC heating is a solution which can be very, very important, especially in countries like let's say in European countries. Why? Because it is the energy problem is very critical, and especially we have seen that after the war in Ukraine. Reducing reliance on fossil fuels and contributing to decarbonization efforts in communities and cities, it can be achieved, let's say, by district heating solutions. As we've seen in previous presentations, there are more than something like 400, I think, district heating systems only in Europe. So that means that there is the understanding of using solar thermal is very important. Also, the benefits of solar DC heating systems, they can cover environmental, political, and economic aspects. The only problem we could say for this application is basically that it is required district heating network. So that's why in some countries this cannot be this solution cannot be applied. For example, let's say in Greece, that we don't have DC heating except 2 or 3 cities. It's not possible to be applied. For example, as you can see in the first photo on the top, this is a system that is realized by our company in Kyrgyzstan. That makes very interesting because it's okay is the first, and now they are going to develop another 92 systems in the next 5 years. So this is very important, and the people, they have seen the advantages of this system. But of course, okay, the main markets for these products are mainly in Germany, Denmark, Austria, Netherlands, Sweden. Not USA, I don't think so in US. So we can go to the next page. And the next segment could be industrial agriculture. Okay, this is already described by Rosie before. Okay, this is applicable in countries with mid-high sun radiation. These solutions are very reliable because solar thermal, as we said, is a mature technology. Of course, it can reduce the energy cost of the investor, and at the same time, also it will reduce the CO2 footprint of where this system will be installed. The most important projects have been done in South European countries, in US, Mexico, and of course in Gulf countries. Next page. Now we are going to see a little bit of some I pick up some markets just to get an idea. Of course, there are many others and maybe even more important, but I just choose some which might be interesting for you. Of course, first of all is Greece. It's our market. Greece is a market with about 270,000 square meters of collectors. The market is dominated by thermosiphon systems, of course, mainly for the production of domestic hot water. In our market, we have managed to cover almost 35% of the buildings. So I feel that we still have a lot of gap to cover. So still the market is not full. This is in our market, we have a very strong local production, of course, with export activity. Practically, that means our market is very, very competitive. We are offering, as I remember, there are something like 27 producers, which members of our association. I think there are even more, a little bit more, which are not. But let's say there are, let's say in the market there are available many options. Therefore, the cost for the end user is very logical, and with existing energy costs, we have managed to have a payback of something like 5 years. In Greece, we are a well-developed market, so EU regulations must be followed. Therefore, the quality of our products are of very high level. Next slide. Okay, the next market close to us is Israel. This is also a very interesting market. It has a size of approximately 100,000 square meters per year. Also in this market are dominated by thermosiphon systems. It's very interesting that it has very high ratio of coverage of the houses. More than 90% of the houses are already using a thermosiphon system. On this market, we will see mainly open loop systems. And also you can see systems with a tank, with a vertical standing tank that makes very different comparing to what we know in the rest of the world. These kind of systems, let's say in Greece at least, we are familiar because we used to produce a similar systems 40 years ago. I think Israel is one of the oldest markets. Started at early 70s. Now, in Israel, there is very strong local production. I think there are about 10 local producers, which are dominating the market. It's the same that this market is, because of a strong local production, it is very competitive. It is extremely difficult to enter to this market. If somebody wants to export in Israel, is extremely difficult because you have to pass to get the approval from SII, which, as you understand, it's let's say there is a kind of protection to local production. Just to give you an idea, for our company, it got almost 5 years to manage to get the approval. But as a market is let's say the quality of the product is very good, and therefore the people have understood that a thermosiphon system is a very good solution for the production of their hot water. Next page, please. Another market which is extremely fast growing is in the United Arab Emirates. There is in Emirates, it is mandatory the installation of a thermosiphon system, mainly in villas. But also you see a lot of installation of pump systems, for circulation systems in hotels, in labor accommodation, and also in industries. In industry, sorry. In the market, okay, there is, as far as I know, there is no local production, so most of the products are imported. Also there, because on this market they really make some, let's say the annual sales are really very high. You see that, for example, they making projects of 3,000, 4,000, 5,000 villas Over there, it's mandatory to install a solar water heater. So the volumes over there are really big. Therefore, you see that the competition is also very high because most of thermosiphon producers are interested to enter into this market. So the only basic requirement is to get the DCL approval for the collectors. We can go to the next slide. Another market is Australia. Australia is also very old market with a size of around 100,000 square meters. On this market, you can find both thermosiphons, but also four circulation systems. There is local production. As far as I know, there are not so many, but at least these few are very big and also with very big export activity. So definitely they are totally covering the market of Australia. So as said, it is a mature market. First of all, because it is very old. Second is there are very serious and big producers. And the people deeply understand the importance and the benefits of using a solar water heater in their houses. Of course, there are incentive schemes. These incentive schemes are very different comparing to the I don't know how it's called, to the territories in Australia. So each one has its own requirements. And of course, watermark certification is required. Beside Australia, also in New Zealand, it is applied almost similar requirements. The next market we can see in the next slide is in United States. In United States is a relative small market, I could say. The main how it's called? Sorry. The main areas where solar systems are sold is Hawaii, California, and Florida. In these areas, you can see direct and indirect systems, and of course you can see also thermosiphon systems, but also pump systems. For example, in the photo, you can see this is a very, let's say, it's something between a thermosiphon system and a four circulation system. As you can see, there is a collector on the roof and there is a small PV panel. So the whole system is driven by this PV panel, which is connected to a DC pump. Therefore, allows the solar tank to be placed on the solar tank to be placed on the basement of the house or outside the house, and the collector on the roof. So it's something between a pump system and a thermosiphon system, because this system is fully autonomous and is not requiring any electricity to operate. In the United States, there is some local production. There are 2 or 3 local producers, I can say very old producers. And of course, in the market, it is a requirement, the SRCC certification. Of course, there are some kind of incentive programs, not directly from communities, but for example, there is running a program from gas utilities. So these gas utilities, in order to avoid paying the penalties for the CO2 emissions, they are offering some kind of subvention to users to install a solar water heater in order to reduce their CO2 the CO2 footprint. So this program, for example, is running only in California right now. We can go to the next slide. Can we change the next slide? I don't know. Oh, okay. Another market interesting to mention is Mexico. This is also an old market, but recently is growing a little bit faster. In this market, we can see thermosiphon systems, but also we will see for circulation systems in hotels, and also a lot of pool heating systems. There is a local production with very, very competitive markets. To be honest with you, as an exporter from Europe, it's very hard to compete with local producers. And of course, in this market, we can see various incentives. It's really a very interesting market, in my opinion, because of the geographical location. It has the perfect, let's say, match of, let's say, high sun radiation and demand, and also is a very big market. I mean, a very big country population-wise. So solar thermal could be a very optimal solution. And at the same time, in Mexico, we can see that there are towns and which they are facing problems with electricity. So, for example, a thermosiphon system could be a perfect option. Next slide, please. Now I pick up one country from Africa. Of course, there are even much more, and maybe more important. Let's say in South Africa, this is a small market. In this market, let's say basically we can see thermosiphon systems in some villas, for example, in some houses. Also, we can see installation of thermosiphon systems in areas which are mainly used for safari and stuff like that. Also, we meet some for circulation systems for industrial applications, and of course, there are a lot of mining projects. At this point, I would like to mention that in South Africa is well connected also to the neighbor countries like Namibia, like Botswana, and so on. In this market, we see some local production, not very big, but for solar collectors. But at the same time, let's say the same companies are very big because they produce storage tanks. To be honest with you, the main domestic hot water production is done by electrical water tanks. So these producers are basically producing electric water tanks. So in South Africa, let's say it's used to be SABS approval. This kind of certification is not anymore so popular, let's say, or even, let's say, it is required, but not so active. But we have noticed that in many projects now the basic requirement is to have the key mark certification. So this is good for the key mark reputation. Next slide, please. So right now, okay, we've seen some markets. Now let's see the barriers that we have to overcome from let's say market point of view. We've seen that in some countries there are import taxes, for example in Brazil, and I don't know about US. Obviously, you've heard in the news recently after the re-election of Trump. He announced that he's going to apply, let's say, import taxes to European, but also to other countries, of course, to support local production. So I'm not so sure about that, but definitely it will this kind of import taxes, customs, let's say, taxes are always a big problem to export products around the world. The second problem, let's say, barrier we have to overcome is the wide electrification policies. This is not a European problem. I think it's a worldwide problem. So we've seen that all politicians, when they think about solar, the first thing that they have in their mind is PVs. This is, I don't know, is not so true, is not so correct. Why? Because when we talk about, let's say, the energy needs, we can see that more than 50% of the needs are in is heat demand. Therefore, solar thermal is more applicable, is more correct to cover these needs. At the same time, I would like to mention that comparing to a PV system, a solar thermal system is 4 times more efficient, is occupying 4 times less space on the roof, and so on. At the same time, we see that there is an unfair approach comparing to other technologies. Again, when we talk about renewables with politicians, the first thing that they have in their minds, okay, beside the PVs, we see that they are the heat pumps and at the same time also wind turbines for generating electricity. So practically, the electrification and of course the unfair approach is something, let's say, against solar thermal technology, which, okay, many of us are already participating in positions, and of course we are facing this problem continuously, and we're trying to change that. The next thing is about the certifications. Sorry, the last 2 things is about, okay, there is a kind of certification complexity. Of course, with the global solar certification network, that could be it looks like a solution. In some cases, it is a solution, but there are also more things. We have more things to do over there. And at the same time, the total cost of the certification is very heavy for the industries. Even with with the solution of the GSEN, still we have to invest a lot in testing our products and certifying our products. So this is something that we have to give a solution, let's say. Because at the end we need all producers to be able to certify their products to ensure that the end user will get a fine product. This is the end. Thank you so much, and of course I'm available for any question you may have. Thanks again.
Thank you very much, Harry. Indeed, a very interesting presentation and very analytical and thorough. Very good.
I hope it was not very long.
I think it's worth it because I mean, it's not so often that we can hear from a real exporter the real experience and so analytical the countries and the difficulties and standardization and certification. I'm sure that we'll have to repeat such a presentation. Thank you very much.
Welcome. Thanks so much.
Okay, we are pretty good in time. We have some time for questions, and now I'm checking the Q&A session. And already I see that we have a question from Tuba, a general question. I'm reading this loudly about the heat purchase agreement for district heating in Sweden. By Rosie, do we have such agreements in other EU countries? Rosie, would you be so kind to give a reply on this?
Thank you, Vasiliki. Thank you, Tuba, for the question. You trigger me to answer about to mention about the heat purchase agreements, as the power purchase agreements are on in most of the countries. In comparison with the power purchase agreements, the HPAs, the heat purchase agreements, are not so well known, obviously. Why? Because most of the renewable energy sources installation are utilizing technologies of wind and solar, I mean, photovoltaics, and therefore they produce electricity, and that's why we have the power purchase agreements. Now, regarding the heat purchase agreements, there are limited. And regarding Europe, we see heat purchase agreements on the rise, being in Spain. We have a largest HPA contract that has been signed by a global peer producer Heineken, along with the energy service company ENGIE, and it was in May 2022. It supplies Heineken's factory in Seville with approximately 28 gigawatt hours, if I remember well, of heating per year. And there are some other businesses that have entered the Spanish HPA market, which is Abor Solar, Solatom, and thermal cooling technology, and also New Heat, if I remember well. So there is a rise in heat purchase agreement, but you know, it's a slow entrance. It is more competitive in large scale projects and in agriculture and agri-food industries. So solar heat is extremely competitive. We see that the heat offers in Spain are about 15 to 20 euros per megawatt hours in Spain, whereas the current gas prices in Spain are approximately 80 euros per megawatt hours. So there are difficulties in convincing the clients of the benefits of those heat purchase agreements, but the economic benefits of an HPA are very big. And the ideal clients of an HPA would be large heat consumers, but they're very hard to win. So this is more or less the landscape of HPAs.
Tuba Hocam, I think you're muted.
Thank you, Rosie. I think Harry also mentioned some district heating applications. I don't know with or without this heat purchase agreement, but Germany, Austria, Switzerland, Denmark, Netherlands, and maybe more are using solar thermal for district heating. Probably they may also have such agreements.
Yes, you're right. You're right about yes.
Thank you.
If you allow me, I would like also to comment on this. Beside, let's say, the large HPA agreements, we have seen very recently there are even with smaller clients. For example, in Italy, there are some smaller ESCO companies which are dealing even with some thermosiphon units. So they are offering such services in a much smaller level, which makes very, very interesting.
If not, we can move on to the next question. That is already replied in written form, but it's good to repeat it if from Derek, very good. Make them uniquely appropriate for a ship. Rosie, I think it's again your.
That's from me as well. Okay, so breweries, I would put breweries in the soft drinks basket generally, and I would say that first of all, breweries need cleaning, washing, boiling, massing, pasteurization, cooling, and preheating of the feed water. So all these processes utilize low to medium, mostly low heat. So when we say low, it's under 100 degrees of Celsius, and most of the times under 80 degrees of Celsius. So all these processes that are comprising the brewing process, the beer production utilize these low to medium temperatures. And this makes solar thermal systems ideal for this beverage production. The energy of the solar thermal system can be supplied either to the process or to the supply level. This application is ideal for solar thermal collectors, flat plate. Another unique characteristic of the brewing process is that the beer consumption and beer production process happens at the summer months. It is exactly when solar radiation is at its highest. So this time coincidence is also ideal for the solar thermal systems. So we have two things. The first one is that the temperatures required from the brewing process is ideal for the solar thermal collectors, and also the timing is perfect for the beer production and the solar thermal production.
Any other point regarding this question? Okay, no. I have a very small question for Haris about the exporting, Haris. According to your experience and knowledge, what market do you think that is the most promising one in the future? And is usually the market competitiveness connected with funding or not? These are two stages questions.
Yeah, I prefer to start from the second point of your question. I think that the market is going to the, let's say, to the subvention schemes. So in Europe, practically, we see that only when there is a subvention scheme, the market is growing. So this is number one. The same situation we see in the United States. And of course, in other markets will follow. The first part of your question, I cannot say that there is a market which will grow more or less. I think most of the markets will have to grow more in solar thermal. Because with let's say with the energy transition, the fuels are going to end. Therefore, there must be another solution. And as you know, okay, as we said before, let's say 50% of the energy needs are heat. So it doesn't make sense to use, let's say, electricity to produce heat. Solar thermal is ideal for the production of heat. So I believe that our sector will grow, definitely, and will grow under incentive and subvention schemes.
Yes, clear. Thank you very much. Thank you all. Let me have a last check for any raised hand or any question that overlooked. No. No questions. Celine, is there any raised hand or something that I didn't check?
I haven't seen anything, but maybe
No.
I can ask one thing to Rosie. As someone,
sure.
as you know, I'm not in any kind of like solar technologies business, but I was just wondering this technology, which honestly strike me, this solar cooling. Rosie mentioned that I think it was in Jamaica, there was this like cases. Rosie, do you think that we can maybe, do you foresee that we could maybe see similar examples or cases in Europe in near future? I mean, considering these extreme heats we were facing in the couple of years, maybe, I think each year we are exposing more heat and it will continue this way, unfortunately. I was just wondering your take on that cooling system, actually.
Mm-hmm. Thank you, Celine, for this opportunity. to discuss about solar thermal cooling. Solar thermal cooling is a very good option for cooling and air conditioning in buildings. In fact, these applications are not confined only in Jamaica, but they are expanded all over the world. We can see solar thermal cooling applications all over the world, in hospitals, in big businesses, in museums, in exposition centers, and in every building that needs cooling. So more recently, we also studied and simulated and did the engineering study of a solar thermal cooling system in Jordan. That was 1 year ago. Now it is installed and it runs completely very good. It's in a very good operation. So we can find solar thermal cooling systems across all over the world. The main point of solar thermal cooling is that solar thermal systems can produce cooling when it is most needed, at times of very high solar irradiation. And that is the main benefit of those systems, because of the time coincidence of high solar radiation and high cooling demands of a building. And this is, this is a very nice benefit and a very nice opportunity of using solar thermal systems, because we have been used to see solar thermal systems only for domestic hot water production, and during summer and all over the year. But when it comes to summer, what should we do with those solar thermal collectors? One very good opportunity is to utilize them, to install a thermal chiller and utilize those solar collectors for providing cooling inside the house, inside the building during the summer. Now, how do they operate? I won't consume your time very much, but as I see it as a black box, we have the solar thermal collectors. They produce heat, and that heat is enters this chiller. We can think of like a heat pump, and this heat is transformed into cold water. So this cold water goes into the building and cools the building, or it is transformed into cold air, and it utilizes the air conditioning loop inside the building and produces cold and dehumidified air. So this is more or less the technology. It is simple, it is mature enough. We have also companies that produce thermal chillers. We have two types of chillers: absorption chillers and adsorption chillers. And I believe that this technology will maintain its share in the market. Why? As you said, Celine, cooling is rising. Cooling demand is rising due to the climate change and due to the stricter legislation and stricter legislation regarding the installation of the building services. The building services have to be more sustainable, and that's why we go to solutions utilizing renewable energy sources like solar thermal.
Okay, thank you very much. The solar cooling is another story, of course, and maybe it's worth to think about the training specialized in or focused in some such cases that are not so disseminated or widely known. and we can enter more in cost, in efficiency, and maintenance and other parameters that affect their further deployment. Thank you very much, all. I don't want to miss the opportunity to thank again ID for the organization, ITU, of course, my collaborator Rosie, from CRES, Leopoldo from SolarHub Europe, and Harry from Samler Company for their support and their contribution here. And of course, thank the participant for joining this training session. As I mentioned before, all the information will be distributed by Celine in email. I don't know, maybe a link. And looking forward to see you in next training or other activities of our project. I give the